To demonstrate Newton's second law, or more accurately, the momentum principle, I made a video of a ball being dropped from rest. I examined its movements in Tracker. The coordinate plane is set up so that positive x is to the right and positive y is up. The axis is tilted slightly to match the camera's angle. To determine distance, I found that the ball's diameter was 15.75 centimeters. This was then converted to meters. I will now run the footage, and I plotted each point over time so that I could accurately find out how fast it was going. This is the VIDLE program I used to model the motion observed in my experiment. I set the mass of the ball to 52 grams, here it's in kilograms. The beginning position is 0, 0, 0, and the beginning velocity is 0, since the ball is at rest. Time begins at 0. Delta t is 0.01, which is a small enough time increment for this model. The gravity of the Earth is 9.8 meters per second squared, and j hat is in the up y direction. For this model, I chose to make drag equal to 0, so that the only force acting on the ball is gravity. For my loop, while time is less than 0.767 seconds, we will calculate gravity, drag, and the total of those two things, which will impact the ball's velocity, and that therefore will change the position of the ball over time. Here I will show the model. Here I model everything is exactly the same, except I have set drag so that force has a play in the motion of our object. I will then again run the module so you can see the difference. This is where I assembled all of the data so far gathered. We have all of the times lined up here, and I have the positions gathered from the tracker experiment here. Then I took all the numbers taken from the models without and with drag, and I created a graph here. The blue line is the experimented positions seen in tracker. Red is the model without drag, and orange is the model with drag. Here you can see that without drag, the object fell much faster than it would have with. And here with drag, it compares very closely to my experimental position. Although it begins and ends at the same positions, in the middle they vary slightly. I have no clue as to why this occurred. If we had thrown the ball, would that have had any effect on the speed or terminal velocity? I would say it would have. It would have accelerated much more quickly and probably maintained that speed, and it might have looked more like a straight line rather than a curved graph.